Hey everyone, welcome back to the next section. We're going to be moving on this time into different particles and kind of seeing how they relate to our periodic table information that we've learned previously. So when we start to go through elements and atomic structure, we're going to see this idea of a Bohr-Rutherford model come up quite a bit, and in the next section you'll actually be doing just a little bit of history and going through and answering some problems on, or some questions on, different scientists and kind of their contribution to the atomic model and what we currently understand of atoms and how they look and that kind of stuff and how they behave. So Bohr-Rutherford, two different scientists kind of working together. One was a mentor of the other, and basically came up with a working model that we'll use within this course to visualize how these atoms look. So basically this Bohr-Rutherford model states that atoms are composed of three subatomic particles. There are protons, neutrons, and electrons. And when we start to go through and visualize this, protons are these heavy positively charged particles, and they're found inside of the nucleus of an atom. So just like you would think maybe with biology class, understanding how the nucleus works, being the center of a cell, these protons, they're found in the nucleus of an atom. Now the number of protons, that just equals the atomic number of the element that we have. So if we take a look at the periodic table and we see, for instance, calcium has an atomic number of 20, that means that it has 20 protons as well. If we take a look at neutrons, this is probably the trickier one of the three, I guess, in terms of calculating, but it's not too bad. It's the neutral particles that have about the same mass as protons, and they're also found inside the nucleus. And so inside the nucleus we have protons and we have neutrons. And in order to calculate the number of neutrons, we take the atomic mass and we round it, and we subtract that from the atomic number. And the atomic mass can be normally found on the bottom of an element. So if we were to look at something like carbon, for instance, carbon has an atomic number of 6 and it has an atomic mass of 12.01. So if we were to take that 12.01 and round that, then we would get 12. 12 minus 6 gives us 6. And just as kind of a quick refresh on rounding, if you have numbers that are 5, 6, 7, 8, or 9, then the number is going to round up. And if our numbers are 0, 1, 2, 3, or 4, then our numbers will round down, or stay the same, I should say. So if we took a look at number 27, for instance, cobalt, it has an atomic mass of 58.93. 58.93, and we want to round this to the nearest whole number. And so in order to round to the nearest whole number, we have to look at the 10th place and decide whether or not this 8 should go up to a 9 or if it should stay as an 8. And it's a 9, and when we have a 5, 6, 7, 8, or 9, our numbers round up, which makes this into 59. So using those little rounding techniques will help us calculate the number of neutrons in an atom. So when we start to visualize these, we're really going to take a look up to number 20, up to calcium. And by clicking on these and looking at the picture in the top right corner, you can kind of get a sense that this thing, the blue circles, they have 3 protons. Red means it has 4 neutrons. And then you can see these electrons kind of around the outside. And we're really going to be taking a look at the energy levels of the rings that compose these. But for now, we're just going to get kind of a handle on how to identify protons, neutrons, and electrons. So as we go through here, hopefully you can see that these are getting larger, right? More are getting added in as you go left to right. And so more protons, neutrons, electrons get added in. Same way if I start to go down, then they just start to get a little bit bigger each time. Okay, and then if I click on rubidium, there's no picture because it starts to look like and behave so like something different. So all through here, we get this sense of increasing electrons, protons, and neutrons for different elements. So, electrons. They're negatively charged particles, so protons are positively charged, neutrons are neutral, and electrons are negatively charged. they have almost no mass. They're incredibly light, and they circle the nucleus at different energy levels. Those energy levels on the outside, those rings that we saw in the last slide, those could also be called orbits or shells. So atoms are electrically neutral, which means the number of protons and the number of electrons should balance each other out, because these atoms should carry no charge with them as they exist on their own. So if I find magnesium, for instance, has an atomic number of 12, that means that it has 12 protons. That also means it has 12 electrons. So a little bit of practice. I would like for you to probably jot down the table in your book and answer the number of protons, neutrons, electrons for each one. And then pause the video, give it a try, and when you're ready, come back and we'll run through the answers for each one and check and see how you did. Alright, so hopefully you had a chance to fill them out. Remember that protons and electrons for us, when they're atoms, they're identical, they're the same. So that means that whatever I write for protons, I'm also going to be writing for electrons. So lithium has an atomic number of 3, which also means that it has 3 electrons. Fluorine has an atomic number of 9, which means that it also has 9 electrons. And I'm just going to go through and fill in protons and electrons down through this list, just because I can read those right from the table, and it does make it easy to fill them in. So helium would have 2, argon has 18, and potassium has 19. So our number of neutrons now, I just need the mass number for each one of them. So lithium is 6.9. So maybe we'll jot this over on the side for the rounding part. So 6.94. That's going to round up to 7. And so, because remember this digit is a 5, 6, 7, 8, or 9, it's going to round the whole number up. So 7 minus the atomic number, which is the number of protons, so 7 minus 3 gives me 4. And moving kind of similar through that list, 18.9 is fluorine. That's going to round up to 19. So 19 minus 9 gives me 10. Calcium is 40 rounded. 40 minus 20 is 20. Helium is 4, and it's almost 4 exact. 4 minus 2 just gives me 2. Argon looks like 39.9495. So argon would round up to 40 in that case. So when you have, just to kind of write this one out, when you have this number rounding this number up, rounding your whole numbers up, and that number's also a 9, that means that this thing's going to change into a 40. 40 minus 18 gives me 22. And then as the last one, potassium, K, 39. 39 minus 19 is 20. So hopefully you did okay with those, and being able to count them what they are. I do have a little worksheet that kind of follows this, just to get you to practice some, and that we'll get into in a second. So the last part in identifying these are listing out standard atomic notation. So standard atomic notation has to be written out a very specific way. The element symbol is written front and center. In the top left corner is the atomic mass. And so in this case we have mercury, and mercury's atomic mass given a value of 201, so that's the rounded value. In the bottom left-hand corner is the atomic number, in which case is 80 for mercury. And really, if I know the standard atomic notation, I can answer all of the other questions, because the atomic number tells me the number of protons and the number of electrons. And when I subtract atomic mass and atomic number, then I end up finding the number of neutrons. So really, by knowing the standard atomic notation, I can identify all 3 of the subatomic particles that are in question. So standard atomic notation, very specific, has to be written in a certain way, the same way that when we were counting atoms, it had to go in the bottom right-hand corner. So now we've kind of taken up 3 of the 4 spaces, going through counting atoms, talking about atomic number and atomic mass in their places. So that leaves one more spot that we haven't talked about, which is really right here, and we'll be getting to that in the next couple of videos. So the last part, there's the next assignment on subatomic particles. If you have any questions, please let me know.